Hello everyone. Today we'll be solving the problem 131 palindrome partitioning. Right. So, what the question state? What is the question state here? So, given a string S, we have been given string S. You can clearly see here. Partition is partition is such that every substring of the partition is a palindrome. Right. So we have to partition S in such a way that every substring of the partition is a palindrome, right? So uh, we have to return of possible palindrome partitioning of S. What we need to return? We have to return we have to return all the possible palindrome partitioning of S basically. Right, so see here, A is a palindrome of itself, A is a palindrome, B single letter is always a palindrome of itself. We know this one, right? So this is fine. Single letter or digit, anything. So it is a palindrome of itself. So this is fine. Double A we have. This is a palindrome. When we read from this one backwards, it is same, right? So see here, a substring is a contiguous non-empty sequence of characters within a string. They have mentioned substring, what it is, contiguous. This word is completely important, right? A substring is a contiguous non-empty, this one, sequence of characters within a string of the partition. This one they have mentioned palindrome we know still. uh, See, let me tell this one loudly. A palindrome is a string that reads the same forward and backward. See here, AA. It reads the same backward and forward. A simple example is MAM, right? MAM. So you can just read backward the same. It reads backward also the same, right? So same goes with every individual letter or the digit, whatever you consider. So it is a palindrome of itself. Just remember this. And B, this one also we have to consider, right? So this is fine. Now let me consider example 2 here. We have only one letter A. A single letter is a palindrome of itself. We know this is fine. They have given us wonderful examples just for the sake of understanding. Now, as we are familiar with the question in the example part, let's discuss the this one. What do we call approach first, right? So let me consider first example itself. What do we call here? We have AAB, right? So we have AAB in the this one. What do you call? Example one basically, right, as input. So this is fine. First we will start from the index 0. This is index 0, this is index 1, this is index 2, right? Zero based indexing. So we will choose A. So first thing I want to tell you is we will be going with a backtracking approach, right? So we will be going with a backtracking or the recursion, right? So just remember this one. We'll be going with a backtracking, right? So we will be starting from the index 0 here. So we will choose A first here. At the index 0 we have A, right? So remaining is B. Now we have chosen A, so remaining is B here. So all the this one, all palindromes are here. So we have considered A. Again A is present, so we'll be considering this one as well individually. So remaining is B, only B, so this will be palindrome as well. So now from the first step we got here A as well as B, right? So this is one set, this is one set, right? So this is fine. I hope this is clear. Next, we can either choose A or double A, right? So this is same letter, right? And it is a palindrome, right? So next what we will do, we will consider double A in case, right? So in case we'll if we choose double A, so remaining will be B again remaining will be B, right? So now all the palindromes are what we found here, this one AA along with this one B, right? So I can just go with this one, single inverted comma, double inverted comma. Everywhere I'll make double inverted comma itself, right? So this is fine. We have got double A and B. This is another set, right? So this is first set we got, and this is second set we got, right? So now we have considered A and B. This is one set, every individual letter, right? So next we considered as we had the same letters, we considered double A, and we were left with only the single letter B, right? So this belongs to one set, right? So this is the second set basically. Next we will be considering all the three letters at once. Nothing means here we will be considering A and B, right? So AAB, is it a palindrome? See, if we read from the backwards, it will be B double A. It is not a palindrome, right? So we will discard this one entirely. what we'll do, we'll discard this one. We don't need this one, right? So we have to collect all the palindromes and return. In this case, the first case, we first set we got this one AAB, and this one double A B, right? So this one we will be returning as output. This one will return in the form of output, right? See here, the output that we got here is AAB and double AB. Both are of different sets, right? See here, AAB and A double A B, right? So the output that we got here is equivalent to the output that they have given for the example one within the question, right? So our approach works absolutely correct in this case. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what will be the time complexity? You would have already guessed, right? So it would be big O of n into 2 to the power of n, right? So n into 2 to the power of n. So why it is n into 2 to the power of n here? Because we are exploring all the partitions and palindrome checks. What we are doing here, we are exploring all the partitions and palindromic uh, palindrome checks basically. So overall time complexity would lead to big of n into 2 to the power of n, right? So what would be the space complexity here? The space complexity would lead to big of n, right? So the space complexity would lead to big of n, because we know this one, we are making use of the backtracking, and backtracking uses quite obviously recursion, and recursion depth would go up to big of n, right? So basically this will lead to the recursion plus path storage. So first path was AAB. Second path was this one double AB. We had two in our case, right? So we are going with the path storage as well, recursion depth and path storage. So overall space complexity would lead to big of n. Time complexity big of n into 2 to the power of n, because we have to explore all the partitions and palindromic checks, or the palindrome checks, right? So overall this one, so the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into 2 to the power of n and big of n respectively, right? So let me do one thing here. We remove this one, right? So as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. First thing is we have to go with the result list, right? So I'll just go with here, we have to save somewhere, right, the result. So I'll be going with the array list. So this will be list string. So this one will be result equals, let me go with array list man. So this is fine. Yep, we are going with the final result list. So this is fine. Now we have to start the recursion from the index 0. Nothing but we have to backtrack here. So for backtracking, I'll not write here itself. Let's make use of the backtrack helper method, and let's make use of the backtrack here, right? So within the main method, nothing but partition. So let me go with the helper method backtrack, or the backtracking function. So I'll just go with private void. So this one will be backtrack. So I'll just go with start. uh, this one will be string s. This is also fine. This one will be list. So this one will be string. uh, this is fine, path. So this one will be list. mm, List. So this one will be string. This is also fine. This one will be result. So this is fine. So within the backtrack method, so first step is, if we reached the end of the string, then we have to add the current partition to the result. So that's what we did in the this one while explaining the approach, the first step, right? So if we reach the end of the string, then we have to add the current partition to the result. Let's go with a simple if condition here. Nothing but start. If it is equal to length of the s, this one, then let me add that one to the result variable. So this one will be new array list. Let me pass the path here, right? So this is fine. Now we don't have to return anything, so I'll just give here return. This is fine. So let me come out of this one entirely. Let me go with a simple for loop man. Why? Because we have to explore all the substrings, right? So we have just started, we have to explore all the substrings. So this one will be int end equals start. So this one will be end less than s dot length. This is fine. And this one will be end plus plus means let's increment the end. So we are just exploring the substrings here. So let's go with the simple if condition here. If is palindrome. So this one s comma start. So this one I'll just give here start. So this one will be and this is also fine, right? So within the if condition, what we'll be doing, let's choose the substring, man. So this is simple. This one will be path dot add s dot substring. So this one will be start. Let me go with n plus 1. So this is fine. We are just choosing the substring here. So first we were checking the palindrome. This is fine. Next we are choosing the substring. Then also it's fine. So now obviously we have to go with a recursion, or we have to recurse for remaining things, right? So I'll just go with, let me copy backtrack here. Let's recurse for the remaining part. So I'll just go with n plus 1 comma s comma path comma result, right? So this is fine, man. Now let's backtrack, means we have to undo the choice. Pure backtracking, complete pure we have almost come to the end of the backtracking part, right? So we have solved a number of problems using backtracking already. So this is fine. Path dot size minus 1. So this is fine. We are just undoing the choice here. Pure backtracking again. So let me do one thing. Let me come out of this one entirely. Now, so I have made use of the is palindrome here already. So I should have written the is palindrome first itself. Sorry for that. So I'll do one thing. We have to make use of the this. We are making use of the helper method is palindrome within the this one backtrack method, right? So now let's go with the utility just to check if the substring is a palindrome or not. So I'll just go with the private here. Boolean. So this one we have made use of is palindrome, right? So let me type this one quickly. This is of the type string s. This one will be int l and r. So this is fine. So within the is palindrome method, first thing is we have to check the characters from both ends, right? Left and right, both. So I'll just go with while left. Quite obviously, it should be less than r. So this will be s dot char. Caret will be making use of this one. If it is not equal to s dot char at of r, so then it has to be equal basically, right? So equal words when we are comparing whether we are checking for the palindrome or not. So if it is not, then we have to return, quite obviously we have to return false, right? So this is fine. Now I'll just go with l plus plus. We are incrementing l and we are decrementing r. This is fine. Finally we have to return, else we have to return true here, right? Else we have to return true. So we are done with this part as well. So I should have written this one first and then I would have made use of this one, right? So I completely forgot. So this is fine. Now I hope you don't get confused. So why did I use this one is palindrome and I had not written the this one helper method is palindrome at all, right? So don't get confused. That's it. So this is fine. Now we are done with the backtrack as well as the helper method is palindrome. We are just checking whether it is a palindrome or not, making use of is palindrome helper method, right? So this is fine. Backtrack because we have to check all the this one, right? What do we call all the palindromes, set of palindromes, right? So that is the reason we are going with the recursion or the backtracking basically. Now let's do one thing. We are left with only two steps. One is we have to start the recursion from index 0, right? So for that I'll be copying here this one backtrack. We have to start from the index 0 as I've said. So this one will be 0 comma s and new array list. This is fine. Finally result area. So we have to return the result itself. So I'll just return result, right? So we are done with the coding part. Let me hit the run button, man. Just give me a second here. This has to work. Return false where line number 25. Twice I have written the twice I have this one. I have made use of the keyword return twice. Sorry. This one, let me hit the run button again. What is wrong here? Oh, this one we are making use of the Java, not JavaScript. Let me give here parenthesis. This is fine. Yeah, now you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly here. This has to work for all the test cases. Let's see. I hope this works. Yeah, you can clearly see here all the test cases are getting passed, means the code works absolutely correct on this case, right? So I hope the solution part is completely clear along with the approach and the complexities part. For now, this is it. Thanks for watching, guys.